Dr. Chang is an associate professor at the University of Texas, El Paso. I'd like to everybody welcome Dr. Chang.
Good afternoon, and thank you, John, for the introduction. It's my pleasure to be here. I want to thank you, the committee, for inviting me to make this presentation. Let me tell you that this project is a 2.5-year project, already completed, has been already published. And I've been delivering different presentations on the topic, and we are really expecting that it will be implemented, what we found here. I'm pretty sure that everybody here is concerned about delay maintenance, right? Everybody has a problem with delay maintenance, or some problems? Yes, raise your hand, you have an idea? Yeah, that was kind of the motivation for this research. The point was that when we got the project, kind of the idea was, can you make a consensus, an agreement, or uniform procedures for all the different assets that a DOT can manage or an agency can manage? Let's say bridges, pavements, culverts, lighting, guardrails. What do they have in common? That was our first question. Can you figure out what they have in common? Well, one of the common points, they are delay maintenance in their own programs. But further than that, they are different policies. There are different ways to define maintenance, and there are different tools that can be applied. And many times there is not even data enough in order to do that. We even faced a situation that when we were doing the research itself and we were asking about maintenance policies, and we said, okay, what about policies for lighting? And we'll have DOT maintenance. No, we just replace it when they fail, all right, period, that's it. So that was gonna be the end of the research. So what I want to tell you, that one of the major challenges about this particular project is to create a uniform framework. Because when we will start looking around, we say, okay, what's the best tool on each area? What's the best data? What's the best practice? And really everybody was claiming this is the best practice. This is the best tool. And when you use one tool, you get one result. Guess what happens when you use a different tool? You get a different result. So which one is best? So the idea for the project was to create kind of a uniform framework, procedure, or guidelines that could be adopted by any DOT, by any agency, following their own practices, if possible, and create definitions that can be followed in order to show the consequences of delay maintenance. And we have an idea like what are the consequences, but when we go to the point how you quantify the consequence, that's a little bit more difficult. So we went further and go, what are the guidelines? We create like a process, and then we apply the process to case studies. And everything is documented in a report already published. It's open, so you can find it by Google, or you can find it just by looking to the NCHRP website. The project is there. 2.5 years project, you may guess, is a very, very thick report. But we have the main body, kind of a big summary. We ended with like 300 pages for the main body, and then when we talked to the coordinator, he said, can you resume to 60 pages? So that was another challenge. I said, how can we do that? Well, let's create appendixes. So there are plenty of appendices for each of the particular assets. So if you want to learn more about the payments, you go to the appendix on payment. You want to learn more about the bridges, you go to the bridges appendix, or the lighting, or the guardrail, or the culverts. So we target different assets, but all of them follow the same kind of guidelines, and I'm gonna present examples. So that's kind of the introduction. So the project is already approved, the guidelines are there, and we are expecting that this will be implemented, because that was the philosophy from the beginning. We were looking for research that can be applied, that is very strong in the concept, is very strong in the modeling, but at the end, the application, the product is easy to follow. So if at the end of my presentation you say, I already knew this, well, that's good, make this common sense, and you can apply it with your own tools. Now, to do that, I was the PI, the principal investigator, but we knew that we couldn't do it alone, just with academia or just concepts, even though I have practical experience. So we assembled a team distributed in different locations, but also with very broad experience. We brought Nichols Consulting, who has a lot of experience on pavements and other management systems, and brought kind of the idea from consultants. We also have SPY Ponds partners who took care of some of the difficult assets like lighting or bridges. And we have a consultant, Roger Smith, retired from Texas A&M, also involved, and other people, and a bunch of students working on running software, running scenarios, and looking what we're getting. So that was the team that I want to acknowledge. I couldn't do it alone. We did a good job, I think so. So the topics that I'm going to cover, I already told you a little bit about the objectives, but I'm going to emphasize how we approach it because I think it's important. Then I'm going to go over the procedure. So what are those guidelines that I mentioned that can be applied to any type of asset to quantify, because that's the key. If I ask about, do you know about the consequence of delayed maintenance, you may say, yeah, there's going to be this and that, but how you quantify, what tools you can use? That's probably a bit more difficult to answer. And that's kind of what's been going, like, yeah, delayed maintenance, yeah, it's a problem, but how you quantify it? What models can you use? What tools can you use? What reports can you show? That was kind of the question that we were looking to answer. And I will present kind of a brief examples how can be applied to pavements and bridges. And the reason is just because those are the most common ones, but we apply the same thing for other ones like lighting, guardrails, signals, and those other assets that I will not really call them minor. They are important too because they are related to safety. And really the whole thing is in the asset management framework. So this is kind of for the strategic level, even though it's tied to project level, it's more strategic level. To get the funding you may need to do your maintenance by showing what happened if you don't do it on time. And then finally, I'm going to summarize what are the contributions and some recommendations for implementation, which we're going for. So the research objective, just to highlight, the idea is to create procedures, set of procedures. So you can see in the report and the appendix that each appendix is kind of a procedure, a sequence, or steps that you need to follow to quantify what's going to happen with delay maintenance. And each of the appendixes will tell you, you can use this model, you can use this indicator. We didn't count like saying this is the best, because I think that the best thing is what you use, right? Whatever you're using, that should be the best, because that's the reason you're using. So what we did was kind of laying out the sequence and giving some freedom to see what tool can you apply or what indicator can you apply. Now, the goal for the whole thing is not to use it isolated, is to integrate all the procedures in one big asset management process. That's really the goal, and get the funding that you really need to improve your strategies, to improve your network, and keep it preserved. So it's a lot of performance-based too. It's a lot of numerical calculations and comparisons that is being done. So those are the research objectives. I believe even though it sounds simple, it's very, very challenging because the assets are different and they are at different conditions and data is not always available. We start looking for the definition. We couldn't find like a standard definition. We create kind of our own, try to keep it simple. So what's delay maintenance? Because even the term was kind of not consensus among different people. We did interviews, we looked at the literature review, and we found reports talking even 20, 30 years ago, but it's still not very clear what's delay maintenance. So we'll start with a definition, and in simple terms, it's something you need to know. You have your plan, you want to do something, some work needed, you are aware this is needed, but then it's postponed. Why is postponed? Well, many reasons, and the major one, if I go around, we will say, well, no money, right? That's one, no money. The other one might be, we didn't know what's the consequence, or we didn't know what's the impact, or we believe that delaying 1 year or 2 years, what I have to do may not cause any impact. We define delay maintenance as work that has to be done to preserve the highway system. And that's another word that can also be is maintenance, conservation. We just said preserve. Preserve might be in a good state of repair. And again, this definition applies to all the highway asset groups. So we have pavement, bridges, lighting, culverts, and I go over more detail. And it's talking also about policies, condition assessment, deterioration rates, service life cycle costs. So it's very broad, very ambitious. And when we were doing this, we thought, oh, this is really hard. I don't know what we get into, but we did it. So that's kind of the introduction, what's about it. And really keeping it simple, we came out with 3 main steps. And again, I believe it will make sense to you, and that's good, because that's what we're looking for. And these 3 main steps that we get was through these 3 tasks that we did. So we conducted first online surveys. We did online surveys with DOTs, with practitioners, about what are the best practices, what's happening, what are the causes. We review a lot of reports, papers, and policies. And then we did focus interviews for those of them that were more promising or giving us more knowledge of what was happening in the DOTs to be applied. And finally, we did runs with performance maintenance scenarios. So we used tools to run and try to prove or demonstrate what we were thinking was the process. All those methods, the tools, are described in the report. We are not taking any particular one. We just have like a bunch of tools described, and we are having a case study for each of the assets with an example. Okay, this is the 3-step process, or the main 3-step process. Everything starts with a policy. What's the policy? And we know that DOTs or local agencies or others may have a little bit different on the preservation policy. So the first step is to define the preservation policy. What's the policy that's going to be applied? The second one is what are the needs for each of the groups? Remember I saying that this can be applied for all the highway asset groups, not only pavement and bridges. So this could be like, what are my maintenance needs for the whole asset network that I'm doing? And the last step is going to be the delay maintenance scenario. So we're going to conduct the scenarios using analytical tools and methods, and then see what are the consequences. And we apply this methodology to the assets that are below, like pavements, bridges, culverts, guardrails, lighting, pavement markings, and signs. Now, do you agree with me that they are different kind of assets? Yes, right? They are different kinds. They have different life cycle costs, they have different costs, different maintenance policies, different deterioration models. So again, what we did was create a framework, and we expanded these 3 steps, and I'm going to show you through examples how we did it. So let me show you first the pavement example, because that's kind of the most common one. So how we did for step 1. And we did it with actual data. I cannot reveal the name of the agency, but we did it with real data. These were the 3 sub-steps in step 1. So asset preservation policy. The first step is to identify what type of maintenance for the asset group. And if we ask around in a survey or just different DOTs, they may have even different meaning, different type of treatments or preference. So whatever is what you have, that's what has to be defined and have a guideline or following what is did for the type of maintenance. So once we define the type of maintenance, we establish the objectives. What are the performance objectives? What indicators they are using, or maybe a group of indicators. And then, well, what's the criteria for the maintenance activity? Many times, depending again on the agency, they may have their own policies, or they may have something in writing or follow something similar. But again, there are a lot of differences. So for the example, there are definitions in the report. So these are kind of the common treatments that we found, and we just referring to other studies. So for alpha payments, we have the chip seals, the cold-in-place recycling, the cold milling, the crack filling, and all of those are the ones that are kind of being considered, should be some way taken into consideration when you are looking at your maintenance treatments menu. Then for concrete payments, because these include both, you have the crack sealing, the diamond grinding, the diamond grooving, and you will find definitions also in the report and references to go further and see what's the meaning of each. So the first step is pick up which ones you are going to use. Once you pick up which ones you are going to use in your maintenance, then you have to say, what are going to be my performance objective? And we will have to pick up indicators like the International Roughness Index, the PSI, the remaining service life. And remember, this is more strategic level, but there is some tie with the project level. It might be also skid number or international frictional index or a combination of those. So you pick at first what are my maintenance treatments, then will be what are my objectives or how you're going to establish my objectives, and then get a criteria that you're going to use. And again, we pick up this one from other studies and try to have the most common ones. And yes, of course, somebody will disagree and say, well, crack sealing is not 1 to 3 years, maybe 1 to 6 or 1 to 7, depending on the product. But you can define or reset those values and check what's going on. So we have to see what's the criteria. It might be a timing cycle, might be when it reaches certain condition, or might be a combination. So this is explained in more detail in the report, but what I mentioned here is that you need some sort of way to define when you're going to apply maintenance, based on timing or based on when you reach certain trigger value. So that's the first main step. And the second one, once you define your criteria, and once you know what's going to be your indicators, then you go to determine your maintenance and budget needs. So you pick up your group, the asset group condition, select your performance models. There are many performance ones around. We are describing also that in the report. And you have to forecast your condition and finally come out what my needs. That's the needs analysis, and you need a tool for that one. These are examples for a particular situation. We pick up a condition index and we make it general, but these are real numbers that we got. So you can see here the initial condition. So what's my condition before the analysis right now? And you can see for this particular example, very poor is in red, very good is some white, but then you have the good and the fair, the majority in green. There's more than 80%. So that's the first step. So kind of we're laying out is what's the process we have to follow and what's the sequence. So the first thing is what's my condition? And then you need to use a model. In this one, we're using a model which is a performance score, but maybe any other one, as long as you follow the certain guideline. So you can see family scores for this one in particular, and this is a deterministic model. There are probabilistic model and any other ones. You pick up the one that probably your agency or your tool is using. The third one on this second one is do the analysis. So we need a tool, and we recommend use, if possible, the tool that you have already implemented, or look around the one that fits your needs the best. So we identify the maintenance activities based on the needs analysis, what needs to be done, and you can create of your program and have to reflect best engineering practices. We didn't want to say, okay, this is better than the other one. It's very conflicting, and that was not really the purpose. So once you do that, we go into what we call the maintenance scenario analysis. This is kind of the core of the research, how you formulate the delay maintenance, how you did it, and what's the impact. So that's kind of the core. The previous one was the foundation. You need a context, my policies, my indicators, and how it's going to be done. And then you do the analysis itself. So for the analysis, it's really a scenarios basis. It's kind of saying, what happened if the two extremes, I have all the money, I don't have any money, or in between the delay maintenance, which are harder to model. Those are harder to model. And then, well, what's the impact? And you're going to see some numbers for the case study that we just ran for payments. There are many scenarios that you can run, but these are kind of the classical ones, like all needs. So if I have all the money in the world, almost impossible, right, infeasible, I can apply whatever I want, so we will not be talking about delay maintenance. And number 4 is budget driven, very typical. I only have this money, what do I do? And then you have the do nothing, kind of a base scenario, that's number 2. So no maintenance at all, no treatments at all. And number 3 is delay maintenance by a certain number of years. So what typically is that delay maintenance, I'm going to delay 1 year, I'm going to delay 2 years or 3 years, and then nothing's going to happen at the end, or it will be minor. So that's kind of what we are looking here. It's going to be minor or not? If I delay 1 year, if I delay 2 years, what's going to happen? Because that's kind of the real question that we have. Now, determine the impact, what we use was, we look at the budget needs, we look at backlog costs, we look at the asset value, and I know there are many others, but in reality, when you see this structure, we're looking at the cost and the condition. So we look at the cost and the condition, and you define the condition by an indicator, and then the remaining life. These are the results, which I think it's worthy to spend a little bit more of time or look at that. You can see templates also in the report to see how you're going to show your numbers. So after we run it, what do you see? All needs, you have to invest, of course, more money. That means doing everything that is supposed to be done on time. That's 325 million. Then you have on the bottom like budget driven, so 0% for maintenance, 181 million, that's the investment. Delay maintenance, 192, and the do nothing is 0. So what do you see in the last two columns? You can see the backlog costs, and you can see the payments in very poor condition. I pick out just only these two. There are many other ones that we are showing. So what we see here, if I don't do anything, well, the backlog cost is going to be 593 million. That's a lot. If I have a budget driven, my backlog is 210. But what happens if I have delay maintenance? The impact is still big. It's kind of half, well, not half, but kind of close to the do nothing. So just delaying. So let's say I have to do a seal crack treatment right now. I delay it 2 years. Okay, I have to do microsurfacing. I delay it 2 years or 3 years. I just delay it. So what's going to happen? At the end, the backlog cost is going to increase, and really it's significant. It's not like just a few dollars. And if you look at the condition, you see here for the do nothing is 45 in very poor, it increases a lot from the beginning. And then for delay maintenance is 18.6, and the budget driven is 35.8. So delay maintenance is not really a good choice or a good option. You have to do something. In addition to the tables, we came up, we kind of condensed some reports that might be interesting to show to get funding. And one might be the payment condition over time. So you just have lines for each of the scenarios, how it's changing over time for each of the scenarios that were run. Another one that can be the pie charts with colors. So at the end of the analysis, 20 years, that is typical. We just pick up 20. You can see the all needs, the do nothing, or the delay maintenance. And the red color is the very poor. So you can see there like delay maintenance is kind of close to the budget needs, and you can see that it's increasing at the end. Another one is the remaining service life, and we keep trying consistent with the colors. So we have the scenarios like the do nothing with the red. We have the number 3, delay maintenance, the orange one, and you can see the differences here about the groups for remaining life. So we came with a bunch of type of reports that you can show based on experience, based on feedback. Another one is the budget needs, like this one. So for each scenario, we create charts, and everybody may have a preference about colors or charts, so you have a bunch, and you could pick up the one you like it. We have the backlog cost, so that's another one that you can see tendency. Can you see the peak over there? Can you see this peak for all needs? You see the peak? What do you think the peak means? Any idea? I wonder if you're still awake. Yeah, what's the peak means? It's a cycle, right? Yeah, remember at the beginning I said set up the policies like the timing, when it's going to be done. So this kind of the timing, that every time, at a certain point, something is going to be done, and that's what kind of we've been seeing, and you can see a tendency. So this is kind of reflecting that one. Here you see also for the all needs, like once you reach certain conditions, you have all the money of the world, which is impossible, well, will stay, supposed to be stayed at that certain amount of money, and the budget needs for 0 is the other one. And I know you may tell me, yeah, are you already doing this? That's good, that's great. What makes a difference is that now you have a kind of a sequence that you can apply also to the other ones. So now we realize that the DOTs are at different stage of maturity in the application, and some are more advanced than others. This procedure can fit into any kind of maturity level. Another good thing about the report that you can look at that, and again, this is for all the assets, is this kind of tables. What are the elements you need to collect? Because many times you even don't know, okay, what should I get? What do I need to quantify it? All right, we said, what data do you need? Payment inventory. That's really 101. You need inventory. You need to know what do you have and what's your condition. So that's kind of basic data. Performance models, there are several ones. Deterministic, probabilistic, Bayesian, expert-based. Everybody has a preference. And then the scenarios, those are the basic ones, the ones that you could run. And then the kind of results with analytical tools. There are databases that we have summarized in the report. Typically, of course, you need a pavement management system to really run the analysis, whatever it is the brand. And then type of reports. So for each asset, we have in the report these kind of tables that you can use. Now for payments, probably simple to figure out. But again, if you ask me, let's say for guardrails, what performance models can you use? How can you predict the deterioration of a guardrail or lighting? Or how can you predict the deterioration of a sign? Well, what indicator can I use? Those were the more challenging. And we have to create some models for some of them, because that answer about we replace it when it fails, that's very typical. We receive that answer from many, many people. That's kind of reactive. But how you program ahead? So I'm going to show you now Bridges, who has a little bit different philosophy in the application, although follow the same framework. So I think the major benefit of the report is creating like kind of uniform guidance and then summarizing the different tools and giving you examples. So let's see what happened with Bridges. Do you remember the first step? I know you have a quiz later today at 5. That's what I was told. Do you remember you have a quiz? Yeah? No? That's what I was told, right? Have a quiz, correct? Anyway, this question may come in the quiz, or maybe not. Do you remember what's the first step in the framework? Anybody? What's the first thing we have to do? The policies. And inside that one, once we define the policy, yes, that's correct. So you have to define the type of maintenance, right? But then if we ask around, we're asking people around for bridges and others, okay, what are the type of maintenance? Or what are the groups? They came up with different definitions. What's cyclical preventive maintenance or bridge preservation? We pick up this one from Federal Highway. So we have definitions about type of maintenance, and one that includes the cyclical preventive maintenance, which will be like, what are the interval when you do for existing bridge, or you're going to look like one element or the whole bridge or just one component. So we have those definitions there. In reality, we say actions or strategies, you can call it different ways, but it's to prevent, delay, or reduce deterioration. You're not talking about really structural, you're talking about more functional. So restore the function of existing bridges. That's kind of the gray area or the overlap. Keep bridges in good condition and extend their life. That's kind of what we are looking for. So bridge preservation includes cyclical preventive maintenance, condition-based, and rehabilitation could be. That was kind of the argument. Should we include rehabilitation? What kind of activities? That was part of the challenge. Try to differentiate also the project with the network level. And we try to follow standards from Federal Highway as much as possible, or DOTs. And you have like wash and clean, thin bonded polymer overlay system, how frequent they are being used. So kind of the timing approach, the asphalt overlays, the rigid overlays, and then we have the other ones. Now then, you have to establish your performance objective, and we found different indicators around. Some of them are more popular than other ones, depending on what you're really looking for. So we have the NBI, General Condition Rating. I think that's one of the most popular, National Bridge Index. Who's using that one? Just an idea. Who's using the NBI? You're using the NBI. Who else is using the NBI? No one else? The NBI. That's kind of, I would say, one of the most popular. But we also have the National Bridge Inventory, which is related on the sufficiency rating, and the Bridge Health Index. Anybody using the Bridge Health Index? I'm just curious. No? Nobody measures the health of the bridge? No? Yeah? You're using the Bridge Index? No? Oh, that's less popular, right? That's what I say, there are different ones. We pick out one for the example, but we're listing all the different indexes that are around, so you can use as a reference to the report to see what else is being done. Remember that we're looking network level, so performance objective, we look at the performance for the whole bridge network, not just one bridge. So we're looking like, in easy terms, which ones are in good, which ones are in fair, which ones in poor condition, and then the percent. What's the percent of bridges in structural deficient? So we're kind of combining, or these are just examples. You can use 1 or 2 or 3 or the ones you want to apply. to check what's happening, and even the breach health index or the number of posted breaches. So that's number two. We have the objectives, the performance objectives established. And then we formulate our criteria. So as you can see, we're following the same guideline. And I can continue with all the other 5 assets and have the same thing. But what is different is in the policies, the actions, and the ways being handled by the agencies. And you have all that information available. So condition states for the ASHTO, we have 1, 2, 3, and 4, good, fair, poor, severe, and depending what needs to be done, what's the feasible action. And then you have the MBI, general condition rating, with the feasible actions. That's everything documented. When you apply preventive maintenance, when you apply preventive maintenance and repairs, when you apply rehabilitation, so that's already documented. And you can even go in more detail, because what is particular in breaches is that you can have it by elements. So if you look at the manuals or the guidelines, you have by element, depending on the type of defect, you kind of go in the condition from 1 to 4, and this has been changes recently, I would say maybe a year or 2 years ago. So you define what's going to be done depending on what's the condition and what's your index. And then when you go to your second main steps, and in the sub-steps, the first thing is to see what's the network condition. And you need, again, an inventory, and we're taking NBIS, NBI data items, because, again, that seems to be the most popular or the most better supported in the National Breach Inventory. That's what we're taking, and we use that data for our example in order to show what are the consequences. So we use that one with some tweaks, because not everything can be done in that tool, depending on the kind of definition. It was one of the team members who were working in breaches in particular. And then the MBI uses what we call like transition matrix to forecast conditions. Instead of performance, linear deterministics, or just family curves, what they use is transition probabilities. So what's the probabilities going from condition 1 to 1 the next year? What's the probability from going to 2 to 2, or keeping 2 to 2, or going 2 to 3? That's embedded in the MBI's models. But again, if you look at the models, and that's just more probably for academia, but affects the practice, the models are not really perfect. There are certain situations that you cannot model directly, and you may have to extract the data to an Excel file, or to mimic what's going with the delay maintenance in particular. So these models are based on Markorian model, and Markorian is based on probabilities, what condition they are changing. Then you do the needs analysis. So we run the needs analysis, and we see what are the goals, and we need to see what's going on, and then formulate the scenarios. That's the most interesting part. And in breaches, we were so excited that we ran more scenarios. At the end, it ended by a report itself that we have to reduce and compress and try to interpret all those numbers. So we did the all needs, no constraints. Then we have no preventive maintenance, delays maintenance treatments, but a given number of years, similar to the payments, budget driven, and then we added 2 others, like only selected breach systems. So we heard that there was a case that maybe we're gonna treat this group of breaches, the others we're gonna postpone. And then benefit cost ratio. That's another way to create a threshold to see which ones we were gonna do in the criteria. We use the NBIS for our runs. That's what we use. And as I telling you, we couldn't use it directly. We have to twist it a little bit or get data into Excel in order to really mimic what's happened with delay maintenance. So there are some recommendations for the software to include the delay maintenance situation. So we use the NBIS, we use actual breaches condition. I cannot reveal the names, but we use that one. We look for different kind of indexes, and you're gonna see the results. There are other ones that I just mentioned here. The ASHTO breach management formally pointies, that's another one that's kind of common. The breach life cycle, BLCA, the project level analysis tool, and there are many other customized or commercial software that could be used for these runs. So what are the consequences? That's the last step, which is kind of the critical one for our research. So we look at the needs, the costs, backload costs. So as you can see, the categories are similar. The network condition, how many breaches or person classified as D, in poor condition, remaining life, and breach network value, sustainability ratio. That's another thing we look, which is a ratio between the investment and what's really needed. And this is kind of the interesting table that you can look at that. So what's the table here that we can see? So you see the scenarios. Remember which ones were delay maintenance? What number? One is do all needs. Number two is do nothing. Which one was that? Delay maintenance is number 3, right? So number 3. So what do you see on number 3? You can see here the agency cost, that's the amount of money invested during the period. You can see the backload cost, and you can see here also the user benefits and what's the agency cost for repair. So really delay maintenance, of course, it's not the worst situation, but it's kind of between or kind of close, because when you're looking at the backlog, this backlog is very, very high. 3A, 3B, you see the backlog compared to the other ones. And what happened was, and I was telling you about the tweaking the analysis, for example, when we were running like the do nothing, and we were surprised that, okay, why the do nothing doesn't have such a high backlog cost? And the reason is simple, because we didn't apply, let's say, a repair, the time has to be done, or just keep going, but at a certain point, the system will recover because you have to have a higher investment and it's no longer called like backlog cost. So you have here also the user benefits, and you have the maintenance, repair, and rehabilitation, and what's going to be the health index has going down. So this is a little bit more complex because the tool itself, and again, each of the assets have their own challenges. What I would say are the major challenges in quantifying the consequence of delay maintenance. I have shown you a procedure. I have shown you already like what's going to be the process. But before I go into contributions or the summary, I just want to reflect on what are the major challenges to figure out or quantify the consequence of delay maintenance. I will just open the room. So I don't know, maybe open questions too before I go into conclusions. So I just wonder, what do you think about the major challenges for quantifying delay maintenance? I've been doing this question many times already with similar answers. What are the major challenges for quantifying delay maintenance? Talking about all the assets, not just payments and breaches. You have seen the results. I have already talked for a while about this. For your cases in particular, what are the major challenges to quantify delay maintenance?
I would suspect just trying to, in a probabilistic standpoint, forecasting how something's going to behave, an asset. You can use roadways again, but just, maybe all of a sudden for concrete pavement, you might think you have another 8-9 years before you have to do some base patching, and then all of a sudden, through repairing some concrete buckles from summer heat, which we're experiencing now just north of Dane County, you're seeing a whole bunch of delamination. So surprise, surprise. And I think it would probably shuffle or throw some chaos, in a sense, into.
Yeah, I fully agree with you. That was one of the major challenges we also face in the research. And I'm saying that one of the conclusions is like we need to customize those deterioration models. And even though there is another challenge related to that, because in order to create those models and customize or calibrate the general ones, which was the difficult part, which one is applied, that's why we couldn't come out with a general conclusion of what's the consequence, but we feel the tendency. What do you need to get those models? What do we need? Data, right. So the other major challenge was data. So is data reliable or not? Can we trust on the data? And we have the two sides. One, there's no data, or there's too much data. There's too much data to analyze. That was the other side. And data was a major challenge, let's say, even for the other assets. Who has data about lighting over time with maintenance costs? It was very hard. So we have to replace that or complement with expert analysis. So we have two challenges, right? One, performance models. forecasting, what's going to happen in the future, and data to do that. What's another challenge? Because we identify the challenges because we want to overcome the challenges in order to implement the approach. If you don't have performance models, if you don't have data, there's no way you can show the consequence of delay maintenance. So what's another challenge? I just want you to make you think. I know afternoons are not good maybe to think about, especially after lunch. But another challenge? You don't have more challenge? That means everything is solved. Huh? Geography? Okay, yeah. What else? There's another challenge. At least there are two more that comes to my mind, very common, and we spread out. And it's so obvious that maybe we don't realize that one. Especially if we try to look at overall, nationwide, in general terms. What's the major challenge? And I mentioned a little bit at the beginning. Consistency. Consistency of what? Exactly, consistency. Even in one DOT, in one state, we did a project for TxDOT just to figure out what are the definitions of maintenance for the districts, because each district was their own kingdom. Yeah, consistency, exactly. That's another one. So each agency will define in a different way what's maintenance. They have their own practice, and it's hard to get a consensus. But the framework fits in that one because it's a general one. Yeah, consistency, that's another one. One more? Yeah, right, yeah. Get like, what's the weather situation? We are working, I just came from California, and we were talking about developing the deterioration models region-wide. I mean, like wet, dry, right? And see what's the effect of rain, and what's the effect of the extreme events. Then it's raining more frequently, we have climate change, believe it or not, but we have it coming more often, yes. So the past might not tell us what's going to happen in the future, because that's another point. One more sounds like when you're in a bar, right? Asking one more, two more, and you don't want to stop. Yeah, one more. So we stop. One more challenge. Generalize the cost? Yeah, that's another one. Yeah, I haven't thought about it directly. That's the one I was thinking. So, but yeah, generalize the cost. The treatment costs are different. So when you look at the impact. Okay, I'm thinking about the issue about, we're talking about different groups, right? So what happened in the DOT? The pavements guys talk to the bridge guys? Or to the guardrail guys? No, right? Yeah, that's common. Yeah, you don't even talk to your neighbor, right? Anyway, so the other issue is communication. So standards for communication get across and get the message done, especially for funding. So nobody believes you, nobody knows. So what's the common language? Yeah, those are the challenges. And that's what we have as a main contributions, like this framework can be kind of that situation that accomplish everything considered for depending on the different practices and can quantify. So we summarize all the best practices in the report, we summarize all the models, we summarize the challenges, what the DOTs were telling us, especially in the appendix, and we summarize the best practices. So again, the procedure is like, has to be what we call agency-specific analysis tools from existing management systems. So the best tool that is there is the one you're using, right? That's usually what we use, we consider the best. You're asking for something else, well, the one that we're using is the best, especially if you are really using it. So that the framework is an easy-to-follow format, adaptable, and ready for implementation. And it's laying out an existing management system, but also provide tools in Excel for those that are not very well developed. And as you can see in this table, just kind of wrapping up, those are the assets that we look at. We follow the same procedure for each. So you have one for pavement, one for bridges, one for culvert, one for guardrail, and we did performance modeling in different ways. We did runs to see what the consequence and prepare very similar tables to the ones that you have seen. Lighting, pavement marking, and signs. And then we explore a little bit more, like what's the process in safety, what could be mobility, but that was too far away. That's really topic for another research. But we kind of exploring that. And we create summaries like this one, where you can have like what data you need, what performance model, and what analytical tools. I just want to highlight the last part, analytical tools, because you can see spreadsheet models. We couldn't really find kind of open software or tools for guardrails or lighting or even modeling. That was kind of the hardest part of the research because of the lack of data, because of the lack of performance models to forecast and figure out what would be the best. So those were kind of created by their own team or taken by some advanced processes that are being done by some cities or agencies. So guardrails, lighting, pavement marking, signs, the same process, but we use spreadsheet tools with very innovative approaches. So finally, the recommendation, we're really expecting whoever is going to be done is to be implementing. We want to implement it. So the first step is make a decision, of course. We have to implement it, the framework, really integrate in the agency the preservation policies in an overall asset management process, update the asset group inventory, condition assessment, because if the data is not updated, well, you will not get good results, service life data, procedures, recording, calibrate your performance models. That's what you just mentioned, like different weathers, different conditions, different situations. And then, well, pick up the tool that fits better your needs, to your data and to what you're looking in your process. And finally, for communication, select the reports that will facilitate interpretation. Make it simple, the best you can. And then, well, this is kind of the conclusion, the whole framework in the plot. And you can see the three main steps, where the three sub-steps, we call it 3 times 3. So 3 main steps, 3 sub-steps. That is overall in what we call the overall framework for asset management that requires feedback and all the different assets. So everything is in the report. This is kind of a brief presentation. I thought my friend Gonzalo, who is the next speaker, hey, please tell me when to finish. He said, you can take all the time, but I'm not going to take all your time. Yeah, and you're not moving, you're not doing any signs, so. But I cannot go over your presentation. So that's the last slide. Is set to acknowledge for the National Highway Research Program. It was really quite an experience for me. When we submit the proposal, we really didn't expect to win. I don't know, there are certain things that when you get the award, you say, okay, yeah, should I celebrate or what? Yeah, we celebrate after we finish. It was really hard process, but we really enjoyed it. That's it. I'm not sure how I did with the time. Questions I hear?
I think we'll try and take questions for the end so we can kind of get moving along here.
That's my email. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.